Hey humans, how's it going? Susan Ruth here. Thanks for listening to another episode of Hey Human Podcast. This is episode 127. It is with Professor David Calkins. He is a professor at Vanderbilt University. He's a neuroscientist, professor of Ophthalmology and Visual Sciences there, director of Vanderbilt's Vision Research Center, and all-around super interesting guy. We chatted about a lot of really fascinating topics. I am personally so interested in the brain and the fact that the more we know, the less we know, it seems. So anytime I meet anyone that delves into brain stuffs, I get very excited. And David and I met on a plane and we got to chatting, and he was kind enough to sit down with me and talk about his research and stuff he knows and stuff he ponders. It was a really great conversation. I want to touch on something real quick. I was having a conversation earlier today, actually, with a friend of mine, and he said, you know, it's really disheartening because it feels like people are just giving up hope that the world is, you know, a dumpster fire and people are just losing hope left and right, and that it's really getting depressing out there. And of course, absolutely, we are more than entitled to our feelings. It's hard to be a human being, but try not to give up hope. Please know that there are a lot of really wonderful people in the world doing really exceptional things, beautiful things, trying to help each other and loving each other and discovering things and shouting from the rooftops about wonderfulness. And it's what you can seek it out. You can find it out there, I promise. Google happiness or good stories or wonderful news. It's not that you should keep your head in the sand and not know what's going on in the world. Of course, that's very important as a member of the human race to know what's going on in the world. But make sure you don't forget to look for the good stuff. I don't want you to give up hope. It's too important. And so keep looking for it, because I promise you're going to find it. Y'all know all the stuff I mention every episode about social media and the Amazon portal on heyhumanpodcast.com. For this episode, on the links page, there's a ton of really wonderful books and information. So I encourage you to check that out. Okay, I hope you enjoy and stay hopeful. Thanks for listening. Here we go. Hi, Dave.
Hi, Susan.
How are you?
Good. How are you?
I'm doing well.
Thanks for coming to see me.
Thanks for having me. You are a very interesting man. I met you on a plane.
Spent a lot of time on planes, yes.
And I'm going to ask you to scooch in a little hair. There we go. Get up in here. Get up in here. All right. So what interested me on the plane was you were working on something on your computer that looked intriguing, but then you had a book, The Seat of the Soul. And I thought, well, that's not congruent in its own way. So that's sparked.
Well, actually, they are.
I know that they are, but it's not generally. So you don't see that very often in science. People aren't that I've met. I'm not going to throw the net out and catch everyone, but I think in a gross generality, it's been my experience that sciencey people not too big on soul stuff.
I agree with that statement, and I would say...
Good, I'm leaving. Here we go.
It's a good place to stop. I would agree with you, and certainly there are some topics that are taboo in your typical daily scientific life. Religion, we don't talk about religion. We don't talk about things that can't be tested experimentally. Broadly speaking, if it can't be tested in a laboratory, we don't talk about it. On the other hand, from my perspective, the only reason to become a scientist is to continue to push yourself towards the greater mysteries of existence. And so I'm a brain scientist, a neuroscientist, and I remember making the choice to become a neuroscientist. I was a mathematics major at the University of Michigan in the 80s. And at that time, and I think it still is true, there were two huge questions. One of them was, where did we come from? Which is really study of the cosmos and how organic life evolved from energy. Mm-hmm. And while I was a math major, I was probably the worst math major in the history of all math majors, and I didn't think that I could handle getting a graduate degree in cosmology. The other great question was, who are we?
A lot of decimal points in that.
A lot of decimal points. The other great question from my perspective was who are we? And in my mind, that brought me to studies of the brain. And so I went from mathematics to neuroscience at the University of Pennsylvania. And I've always tried to stay focused on the big questions in neuroscience. And there's an awful lot that we don't understand. And neuroscience began really with philosophy of mind. René Descartes spent a lot of time postulating what is it that makes a human being, and the seat of the soul was something that he came up with. And over the centuries, a lot of philosophers would dabble in that realm. And this is before we understood what nerve cells were. And so they would try to understand where personality came from, where religion came from, where spirituality came from. And it brought them to the question of what is a human being, what is a soul. And so in my mind, studying the brain and trying to understand questions that we can't yet test empirically are the same thing.
Mm-hmm. Do you think who we are is inside the brain or outside the brain?
Well, so that's a really, really great question. And I think that 99.999% of neuroscientists would say, well, obviously the question is the brain. And yet there's a small cohort of really smart physicists who think that who we are and the soul is something elemental, and that the brain is simply an antenna for this elemental energy. Mm-hmm. Now, this stuff is not testable in a laboratory, okay, but it's fun to discuss. And so I err on the side of the brain is complicated. We don't understand much of higher level cognition. And I think the safe money is that who we are is inside our head. But at the end of the day, I'm not sure it matters all that much.
Right. It's interesting because your specialty is the optic nerve.
Yeah, that's right. So my day job is I study diseases of the optic projection to the brain. I'm the director of the glaucoma, macular degeneration, retinal dystrophies, optic neuropathies, things that cause irreversible blindness. So,
right. Looking at the eclipse like a ding dong.
Yeah, don't look at the eclipse. Right. So during the eclipse, because Nashville was in the path of totality, there was a lot of press going on about how to handle vision during the eclipse, what not to do, the proper safety glasses to wear, and how to enjoy it without burning a hole in your eye. And I was very busy at that time.
A lot of people.
Yeah. So being a scientist at a major medical center the way that I am, it's really about leveraging your ideas into tangible results.
Right.
And so while I enjoy talking with neurophilosophers about things like the soul or what it means to be a human being, there's a practical side of me that I really want to spend my days trying to cure something. Mm-hmm. Because I think it's useful, and what a great place to do it in the visual system.
I think it's a beautiful irony that you're curious about something you cannot see, but all your work is really devoted to what you can see.
I've never thought of that. That is a beautiful irony.
Yeah,
I agree. Yeah.
I like that.
That's a good way of looking at it.
I was reading a little bit about some of your work, and there was something that caught my eye in one of the articles that I read, and it had to do with that you found in your research what was originally thought that the brain, when it is shut off from the visual field, mm-hmm. You thought that, or they thought, not you, I'm talking about the royal you, mm-hmm. I suppose, mm-hmm. Scientists, mm-hmm. thought that those, I guess, synapses or whatever would start to necrotize. They'd die off so that you couldn't see anymore, but you have found that, in fact, the brain struggles really quite hard to actually make sure that the blindness doesn't happen. And I thought that was fascinating.
It is cool. So it's a bit of a paradigm shift. What's interesting is studies of neurodegenerative disease have really been focused on it being a one-way street where there is a stress, Alzheimer's disease, Parkinson's disease, blindness, a stress, and that stress at some point is too much for the the neural circuits to overcome, and things just begin to die. And once they begin to die, there's nothing you can do about it. So, but what my research has shown is that there's a period of time, a window of opportunity, during which nerve cells in the brain will fight back against stress by boosting their own activity, which is really not all that surprising, because what nerve cells need the most to continue to thrive is activity and connectivity with each other. And so we think that this sort of intrinsic capacity for the brain to fight back against stress is something that we can leverage in developing new therapeutics. So it seems intuitive, but we neuroscientists tend to be a little bit fatalistic when it comes to diseases without really looking at the natural response of the system to stress.
Why do you think the brain does that?
So it's interesting. I think because nerve cells in the central nervous system don't regenerate. Okay, once they die, they're gone, and you can't replace them.
Don't do drugs, kids.
Don't do drugs. So there's a few cells in the recesses of the brain that can become new neurons, and there's a little bit of neurogenesis that takes place.
And this is different than plasticity, right?
This is different from plasticity. There's a little bit of neurogenesis that takes place in the adult brain, but for the most part, once something is injured and dies, it's gone. And that is especially true of white matter tracts like the optic nerve, okay, or the other cranial nerves or the spinal cord. And so I think a nerve that is stressed will signal to its neighbors that, hey, I'm in trouble, boost my activity. Because if that doesn't happen, then that nerve is then targeted for elimination.
The chopping block.
And what's interesting is that actually takes place during embryonic development.
Really?
Yes, yes. And so in the retina and optic nerve, you're born with more nerve cells than you end up needing. And the nerve cells, they hedge their bet. And so nerve cells that compete well and synchronize with their neighbors survive. Those that cannot synchronize with their neighbors are targeted for elimination.
It's a good metaphor for life.
It's a good metaphor for life, yeah.
What I thought was so interesting about that article is it got me thinking that, so we have a hole in our optic nerve, correct? And the brain fills in the spots that's missing?
Well, so that's a different kind of phenomenon, okay? Yeah, so naturally there's no information that comes out of your retina where the retina meets the optic nerve. That's our natural blind spot, okay? But we don't walk around with what is known as a scotoma. And higher level visual processing will fill in information where that natural scotoma is. Now, you can still see your blind spot if you try. There are exercises that you can do to demonstrate the existence of a blind spot. But during the course of normal viewing, you don't notice it.
I'll put some of those on the links page on HeyHumanPodcast.com.
There's a little bit, there is some evidence that in glaucoma, which is the most common optic neuropathy, about 80 million people worldwide, that's the disease that I specialize in. There is some evidence that the brain will fill in missing visual fields between the two eyes so that you always have a full complement of vision occurring. But again, that's temporary, and it's.
I just find that specifically fascinating.
Yeah.
That the brain says, "Oh, we're missing a section. Let's fill it in." And so that's what got me thinking. I thought, well, if the brain is of its own accord doing this, sort of different, it recognizes there's something missing and fills it in. Then does that mean in the future, perhaps, we'll be able to create maybe even some sort of a robotic eye or something that's relaying the information, and that it'll restore sight?
That's the hope. That's the hope. So the field of, right, so you made a bunch of good points. One of the good points that you made is that the adult brain has the capacity for much more plasticity than we gave it credit for. It has much more capacity for plasticity than we originally
Explain
thought.
what that is.
So plasticity is in neuroscience refers to the phenomenon through which different circuits are revealed at different times to maintain function, but also to the capacity for circuits to renew connectivity in different ways during particular stressful occurrences or environments.
For example, my eldest brother had an aneurysm, and he was in a coma, couldn't talk, he blew out his optic nerve, all this stuff, and he had to relearn to talk, to walk, to eat, to go to the bathroom, and all this stuff. And now he's functioning because the brain found other ways to get there.
Sure.
And that's what plasticity
Yeah, so that is, broadly speaking, plasticity is included in that phenomenon.
Yeah. I find that fascinating.
Yeah, or that phenomenon is included in plasticity.
Yeah,
depending on how you look at it.
Is it possible someday to get the brain to talk to
a circuit?
I mean, they're doing it now, right? With people that are missing arms and legs
Well, that's a little bit different. I mean, so that the use of prosthetics involves muscle memory and feedback systems. So we have very, very sophisticated circuits now, digital circuits that will feed back, basically biofeedback to amputated limbs and things like that allow performance of everyday duties. What you're talking about, though, is a circuit that can integrate with the central nervous system, and so that's really one of the holy grails of biocybernetics.
Super complicated.
Yeah.
Right.
Yeah. Super complicated. And yes, there's some evidence that we can get nerves to fire impulses in response to activity coming off of a microchip. All right, so there's progress being made. We also have some progress in building electronic retina that can send rudimentary signals to the brain. And then one of the key questions is, well, what is that information? What is the brain doing with that information? So I think it's promising. These are very, very early days, and one of the most promising areas that I think is in the use of what we call bioscaffold, or neural scaffolds, which are compounds that will promote the integration of nerve cells with exogenous materials such as a microchip.
So cool.
Yeah, so we're at the age where...
RoboCop.
Yeah, RoboCop. Actually, that's a great movie. I love science fiction. I think that we're at the age where chemistry and electronics and neuroscience are all sort of blending together in very interesting ways.
This is why it's important for science to communicate with other science, to
Absolutely.
communicate with other science,
Absolutely.
to communicate with other
That's a great
philosophy.
point. That's a great point. I think one of my criticisms of modern biomedical science is that by the very competitive nature of the beast, it forces you to enter a silo and compete within that silo.
For grants and
yeah, and so we really need to do a better job of rewarding folks who are able to step outside of their own silo and bring other silos into the barnyard to talk to one another.
Right. I suppose there is a couple places in, say, Switzerland that do that.
Yeah. Some of the bigger think tanks do a great job, but those think tanks tend to be supported by endowment.
Of course.
Right? Whereas most biomedical scientists in the United States have to compete for funding with each other through federal agencies.
Yeah. Why did you seek the eyeball as the thing?
Well, so I was always interested in neuroscience and the brain. Even as a child, I was fascinated by the brain, and I loved all the old science fiction movies with brains in jars and things like that. I was fascinated by Frankenstein. I loved Frankenstein.
Abby Normal?
Yes, exactly. and so I read all of Mary Shelley, and I was fascinated with the idea of artificial intelligence in the brain. And so when I went to college at the University of Michigan, I immediately tried to find a neuroscience laboratory to work in. And I didn't really care at that point which one. But it turned out that the only place that would take me was a neuroscientist working in the Department of Ophthalmology at the Kellogg Eye Center at the University of Michigan. And so I entered my freshman year there, and I fell in love with the visual system. And it turns out that a large majority of your brain is devoted in some way to visual processing. Human beings are very, very, very visual. It's our predominant sense.
Men especially.
Thank you. I'm not going to touch that. And
but it's true.
So I ended up learning a lot about the brain by studying the visual system. Yeah.
Is there a favorite part of the brain that you are?
Well, I love all of the visual cortices.
Yeah.
And how they talk to one another. So I like to look at the brain in terms of parallel processing of information streams and where information is coming from and how it's parceled to different parts of the brain. Mm-hmm. And so I'm fascinated by interactions between cortical areas. But honestly, there's so much to learn by studying a single white matter tract like the optic nerve, and there's enough going on in there that you can learn so much about how information is utilized by the brain.
I love seeing the pictures of the inside of the eye. Mm-hmm. It looks to me like a nebula or something.
The retina.
Yeah. I think it's so beautiful, and it always makes you think of the idea that, or not the idea, the fact that we are made out of the particulate matter of the universe, really.
And every particle that comprises you was here at the beginning of time.
That's right. I love
that idea. It's interesting, isn't it? Yeah. So one of the more fascinating aspects about neuroscience is evolution. And how did we become consciousness? I mean, we can get into a big debate of whether we truly are consciousness, whether we truly are conscious, or is it some sort of grand illusion that we subject ourselves to?
A hologram.
Yeah, exactly, a projection. But assuming that it's real, how does one go from a single-cell organism to a vertebrate to the mammalian brain to the primate brain?
Wheaties, I think.
Yeah, maybe. It's fascinating. We don't have answers to that.
Yeah.
We just don't have answers to that.
Yeah.
Are there levels of consciousness? Is we like to think that we are the highest level of living consciousness, but we have
we're also very arrogant.
We are very arrogant, and I mean, sort of an anthropomorphic view of the universe, and I think that for scientific purposes we often assume that animals are less conscious than we are, but maybe consciousness is graded in some ways. It's difficult to test these hypotheses. We can't yet create consciousness in a dish. We certainly can't create it in artificial intelligence, although I think that's probably the goal.
Close. I feel
that's the stuff of science fiction,
which
is.
And then there's the question: if let's take a sociopath or even a psychopath, for example. Mm-hmm. They lack empathy. They mirror in order to function in society. So what makes a psychopath or a sociopath that much different from what we could create in an AI? I think about stuff like that too.
These are great. these are important ethical issues. Really, really important ethical issues.
I think most of us don't have any ethics.
Well, I think going back to the silo analogy, this is one of the reasons why it's important to step outside of your silo and think about the greater ramifications of your work, the ethical ramifications of your work, and especially as we push towards artificial intelligence, but also uses of things like embryonic stem cells and or stem cells that are derived from other human beings. Sure. I think it's important to push these technologies forward because that's how the species evolves, and that's how we cure disease. That's how we better life for humankind. But I think it's very, very important to keep your eye on the prize, which is to not lose sight of the greater ramifications of your work. Where does all this work fit into the great conversation?
It's interesting. On the plane, we talked about religion a little bit, and you are Catholic?
I am.
Yeah. And again, that's what, in the conversation we were having, I was like, oh my gosh, I have to get him on the show because I love the idea of marrying these two things. And I think science is its own religion. I believe that for having great conversation with my father, who definitely is scientist through and through. And but we still talk about the nature of God and philosophy. So given things like stem cell, in my belief system, I feel like I do believe in something bigger than myself. So I believe that thing, whatever you want to call it, has given us intellect, free will, choice, all that stuff. And it is divinely pushed that we figure out how to make us better, how to, improve the being of beingness. how do you see that as somebody who is raised in a faith, who's also a scientist? Where do those things come together for you?
What I've learned in being a scientist is that in order to function in a practical sense as a scientist, you have to put a lot of your personal beliefs aside when you work. Now, having said that, I think it's also important to raise issues that are endemic in religion as you pursue conversations with other scientists, especially when you get into public policy and funding of science. I don't like to take a hard stance on things. I find that when I take a hard stance on things, I increase the probability that I'm going to have to make an apology later on. and so I try to remain open-minded. I see my job is to facilitate the conversation, to keep everyone honest as we discuss topics like embryonic stem cells, as we discuss the existence of the soul, as we discuss artificial intelligence. But to me, there's nothing inconsistent with being a scientist and practicing any religion. You know, I think that right now, what's important to me is I have a good sense of who I am, and what I've learned about being a Catholic is once you're born a Catholic, you're always a Catholic. And but when I practice my faith, I interpret it through the lens of a scientist. What is this teaching me? How does this relate to what gets me out of bed in the morning? How does it motivate me? I try not to get caught up in literal interpretations of anything. I think that God is complex enough that to try to paint him into a corner is folly. And so I don't see anything inconsistent.
I love that. That is so beautifully said.
Thank you.
Yeah.
So I don't see anything inconsistent with being a hard-nosed neuroscientist or being an engineer or an architect with practicing your faith. I think they reflect one another.
I agree with you. But
Well,
I think
you.
a lot of people, that wasn't platitude, it's just it's just the facts. But I do find that many people I speak to a lot of people that there are many who believe that you can either be one or the other. I think that's so limiting.
I think it is limiting. Right now I'm reading the biography of Leonardo da Vinci. Yes, by
There's a dude.
Walter Isaacson.
I love Walter Isaacson.
Walter Isaacson, who I think is the greatest biographer of our time.
Did you read Einstein?
Of course I read Einstein.
So good. I kept my dad on, well, he's already on speed dial, but I was on a road trip and I was doing that on Audible and I kept having to call my dad. I'm like, could you please explain what I just read? And then we'd have a conversation and then I'd go back to the book.
One of the things I don't share often is I'm also a poet.
Oh, very cool.
I enjoy writing very long, very complicated poems, and over the years, people have asked me who know about this habit of mine. Well, you're a scientist. How is it that you also practice writing? Well, I love creative writing. I do a lot of editing of creative writing for friends and sometimes colleagues as well. And just in the same way that I love to read good science fiction or poetry for that matter. And I've spent a lot of time in my career thinking about, well, what is the difference between science and art? And the more I learn about the two of them, the more I realize that they're really not all that different. It's simply, for whatever reason, human beings have a need to make distinctions, to separate things and create divisions where there really aren't divisions naturally there. And I think understanding where art comes from in the brain is as interesting as understanding where religion comes from in the brain, or spirituality. And these practices are not all that dissimilar, depending on your approach. And I tend to approach things very, very rationally. But even in the laboratory, I follow intuition a heck of a lot more than most people. And I will spend a lot of time and resources chasing an idea because my intuition tells me that there's going to be something interesting at the end. And I don't have a basis for that. It's a hunch. Certainly intuition grows over time the more you practice something. But sometimes I just like to freewheel it. And I will invest in a line of investigation just because I have a sense that something interesting is going to happen.
Where is intuition do you think?
Oh, wow. I think it's a combination of things. I think it's a combination of long-term memory. I think it's a combination of emotional intelligence. I think it's a combination of creativity, but also there's a rational basis for it. In that if you examine past experiences in sufficient detail and store that information, and then become comfortable accessing that information without necessarily looking at all of the detail all at once, you come up with a pretty good intuitive sense. And so I think it's a combination of all of that.
Do you think that our subconscious mind holds more information than our conscious mind?
I think there's a heck of a lot of information in there that we don't consciously access.
Mm-hmm.
Absolutely.
Mm-hmm.
Absolutely.
I read an article a long time ago about a device that was created for the blind, but I believe it's for blind that had once seen, but I can't recall exactly now, but it was a chip you put on your tongue.
Sure.
And then as you...
Yeah, and you learn to associate signals coming from the tongue with navigation. And
it actually, you wear these... What is it? No, you don't wear glasses. I forget what it is. It shows you these sort of shadowy images, but yeah. I remember reading about this woman that could walk through New York's...
Well, okay, so that's great. And when we read things like that as scientists, we become excited. Mm-hmm. But I also have a very healthy skepticism of much of what I read out there in the scientific press. And
really?
Oh, sure. Oh, sure. Absolutely. You have to.
Yeah.
You have to. There's so much happening right now. There's so many people doing incredibly interesting things. Not everything that glitters is gold. So I want to see something 10 times, then 15 times, and then I want to see it 50 times. And then I want to repeat it.
Yeah, well, I mean, that's science.
Yeah.
And I've mentioned this a million times on this podcast, that my dad, when I was younger, blew my mind when he said, I was talking about something about science being proven, and he said, you're under the misinformation that science is about proving something.
No, science is about disproving things.
Yeah, and when he told me that, it changed the way I saw everything.
Right. So this is something that I teach my trainees very, very, very early on. Our job is not to prove anything. Our job is to set up testable hypotheses and then attempt to refute those hypotheses. And a theory can never really be proven because you can't test it in every imaginable condition. All right? And so, but evidence builds that supports a theory. Mm-hmm. And then it sort of becomes a statistical game where, yes, we can't prove it or test it in 100% of all possible conditions, but once you hit 90% of the testable conditions and everything starts to make sense, you begin to, for practical purposes, adopt it as truth.
So then how do you research the soul?
Well, so that's a really great question. I don't know, and that's a question that scientists and philosophers and artists and religious figures have debated for centuries. I suspect that as we try to build artificial intelligence, this will be an exercise in learning more about being human. Right? So when we start building robots, what do we build robots to do? We build robots to mimic human activity. Okay, so if we're going to build a robot to mimic human thinking, then it's really going to cause us to re-examine what we know about thinking and to build new tools to probe thinking. So I think that right now we're in the stages where we're just trying to establish the catalysts for testing things that are in many ways ethereal.
Mm-hmm. Intellect in its own way is ethereal, is it not?
Intellect itself is ethereal. We don't really know. We know that there are specific circuits for specific functions, but to try to understand intellect, even try to define intellect, is difficult. And again, I don't like to take a hard stance on that. When I interview trainees or for potential slots in PhD programs or medical school, I sort of briefly glance at their test scores. I briefly glance at where they came from, what they've done, their achievements. But what I really want to know is how does this person think? Is this person a good team member? Is this person curious? Is he or she driven by curiosity? What are the motivating factors? And so we can sit in a room and we can argue about metrics of intelligence without really understanding what intelligence is. We can describe what intelligence allows, but describing what something does only brings you so far into understanding what that thing is.
All right, so now I want to go back to the soul again, because really that was what inspired me in the first place. But
this is why you never talk to anybody on an airplane, by the way.
It's because you end up here. Yeah. I'm thrilled. So you were reading The Seat of the Soul, and you asked me a question. Do you remember the question?
I don't remember the question. I ask a lot of questions.
You said, where do you think you said, do you believe in a soul? And I said, yes. And then you said, where do you think your soul is?
It's just sort of I like to poll people on what they think of
So let's talk about that a little bit.
Go ahead.
I'm going to flip it onto you.
Where do I think it is? Well, so that's you're gonna try to pin me down,
no.
and that's cool. So I think it would be foolish for me to make the same mistake that Descartes made, which was it's in this portion of the brain, in this region of the brainstem, because it looks weird and it looks funny and we don't know what it does. So maybe it's the seat of the soul, or there were other.
It's like the uvula.
Yeah, right. Yeah, exactly. So I'm not gonna make that mistake, and I'm also not gonna be glib and say, oh well, it's in the brain. I mean, without the brain, we don't have the capacity to ask these questions. All right, and so it's sort of meaningless to just say, well, it's in the brain. So I think there's an interaction between the brain and sort of how that brain interacts with the environment, sort of the essence of being human, okay? And so, I believe in the soul. Sure, I believe in the soul. Absolutely believe in the soul. But to say what is it that harbors the soul, I don't think I even have enough information to ask the question appropriately, to be honest with you. So I'm not going to let you put me down. I'm going to deflect it. But it's awfully fun to talk about that.
Definitely.
Right? It's awfully fun to talk about that.
I like to think of the soul as something that lives within and without us.
I think it is. I think it is. I mean, but it's a lot like personality. It's in us, and yet it's something that doesn't exist in the absence of others, or in the absence of an environment to bounce off of.
In my whole existence, I've only met 2 people where I thought, this person has nothing.
It has no soul.
And it was creepy. It was very unnerving. To the point where one of these people, I was in a wedding line to shake hands with the wedding party as an attendee at the wedding, and I got to this person and I went to extend my hand and they looked at me, and it sent such shiver through my body that I just sort of bowed and moved on. Didn't even want to touch this person. It was the creepiest
That is creepy. But so as a neuroscientist, we're exposed to different levels of affect disorders. And I think that sometimes it's tempting to...
I don't think it was this autism. Yeah. I think this person was actually...
Or Asperger's syndrome or something like that.
I don't think it was that, because I've been around people like that, and it's... and that's not... This was
people have, I mean,
different. This was like almost... I can't even describe it. It was like they just weren't even in there.
They weren't in there.
And it was super unnerving.
Yeah.
And then I found out later that this particular person was not a very nice person either. So maybe my visceral reaction had more to do with their personality that I didn't know other than in the first energetic transference, which I think happens with humans. And that's the other thing that I think is so fascinating, is the idea that we are constantly giving off energy.
That's true.
And it's commingling, and then it's transmogrifying, and it's...
So one of the questions I like to ask my students, and I used to teach a course on integrative neuroscience here at Vanderbilt, and I would talk about topics that weren't in the textbook, that you couldn't find in literature, that were difficult. And so I would challenge them to describe what happens to the energy that keeps their brain going once they die. And we would get in these great debates about what happens to energy generally. And because energy and mass are about the same thing. So if the mass is disappearing, what happens to the energy, and vice versa. And these are not answerable questions. They're not answerable questions right now. We don't have the tools to answer these questions. But it's fun to challenge students in particular on their thinking on these topics that they would encounter typically in a course on world religion or a course in philosophy, but certainly not in a neuroscience course. And from my perspective, that's the whole point of the neuroscience course is to get to these questions.
They seem like they would be perfect bedfellows, because how do you even find your hypothesis without dipping your toes?
Yeah, so where is the soul? What is the soul? I think the answer lies somewhere inside, as you said, and also outside, and how we interact with others. Which begs the question, is someone who is born in isolation and lives in isolation capable of harboring a soul? And I think your answer would be, of course.
My answer would be, of course.
Of course. And yet, there's a sense of incompleteness about that scenario.
How do you mean?
In that, I think to reach your potential as a human being, I think it's important to bounce into other particles now and then and gain their energy.
Mm-hmm. What about being raised by wolves?
Yeah, that's that. I probably saw that movie too. I'm sure. Yeah, the boy who was raised by wolves.
Yeah.
Yeah.
I mean, going back to the beginning of this conversation, where you talked about who gets dominion over whom based on some level of intellect or empathy and
the capacity to use tools.
Right. So
and language.
Otters use tools. Chimpanzees, or the monkey family, use tools. Octopus use tools.
Yeah, octopi are actually very intelligent.
Yeah. I've never had an octopi.
Grilled with a little garlic and basil is delicious.
4 and 20 blackbirds baked in an octopi. There's a lot of animals that use, a lot of mammals use tools.
Mm-hmm. Mm-hmm. Exactly, and you can't define consciousness or intellect by any one metric. And when we try to devise metrics to be as inclusive as possible, we fail. We fail because there's always an example out there that challenges how we think about it.
And I think human beings, the tribe of human, wants to feel dominion.
I think it's natural. I mean, we tend to be as a species narcissistic, and we utilize the environment in ways that other animals do not. We populate in ways that other animals do not, but then we push forward out of our environment in ways that other animals do not.
Do you think that is generally on the shoulders of the outliers? Or?
Oh, The Outliers. So that was also a good book. Yeah, I think The Outliers.
Malcolm Gladwell's book.
Yeah, that's right. And Outliers. So is it on the shoulders of outliers? I guess so. But on the other hand, they utilize information that comes from the great conversation that transpires. So I think we all bear responsibility for where we go as a species.
I agree with that.
Yeah,
too.
I mean, otherwise, if we just leave it up to a handful, well, we know what happens when you leave decisions up to a handful.
Mm-hmm. It gets quite dangerous.
It gets dangerous
rapidly.
Yeah, exactly.
Yeah. All right. You just received a big grant.
An award.
An award. Talk about that.
Right. So I received something called the Stein Innovation Award from Research to Prevent Blindness, which is one of the major funding agencies in the United States for vision research. The award was named after Jules Stein. Jules Stein was not only an ophthalmologist, but also a Hollywood movie mogul. And he founded, I think it was the Movie Association or Motion Picture Association of America. And he hung out with all of the people that created Hollywood in the 30s and 40s.
Back when movies were really good.
Right. So what's interesting about Jules Stein is that scientists know him as an ophthalmologist, and everyone else knows him as a Hollywood mogul. And so this association, the Research to Prevent Blindness, hands out just a small number of these awards. It's not every year they hand them out, but it goes to really promote research that tries to shift paradigms in our understanding of blindness and our quest to devise new therapies. So I'm very honored to
That's
receive that.
Congratulations.
Yeah. And they've been an excellent supporter of mine throughout my career, starting with Career Development Awards to Senior Investigator Awards, and now the Stein Innovation Award. Interestingly, I've also won the Lou Wasserman Award from Research to Prevent Blindness. And Lou Wasserman was a friend of Jules Stein, not as an ophthalmologist, but as another movie mogul.
Really?
In Hollywood.
That's
yeah.
fascinating.
So I guess I'm destined to someday be present on a movie set, maybe as an extra in a zombie movie or something.
Maybe, or a scientist or something.
Yeah.
From where you began your career as a scientist, as an ophthalmologist, what did you think then that now you're absolutely 180 degrees from?
So that's a really great question, and I think the quick answer to that is I've come 180 degrees in understanding how nerves respond to the things that kill them. And I think early on I sort of bought into the textbook version of disease where something bad happens and then things peter out and then they die. And I've not only come 180 degrees, but I like to think that I've been at the forefront of driving that viewpoint in the opposite direction, that in fact nerves will fight back to try to hang around as long as they possibly can. And so that was a big turn for me. And in fact, the funny thing, you mentioned this paper that we published on neurons fighting back. When I said, you know what, let's repeat these experiments. There were experiments coming out of other labs that sort of towed that party line that, oh, look, everything's dying and isn't this boring. And I thought that was just too glib. And so I put some time and resources into developing a project, and some of my staff, who are incredibly talented people, said, well, you sure you want to do this? This is, the party line is that things are dying. I said, yeah, let's take a better look at it. Let's take a better look at it. And so we looked at things a little bit differently, and we found this amazing result.
So cool.
And part of that result is what led to the Stein Innovation Award from Research to Prevent Blindness.
Glaucoma is that a form of cancer?
No, glaucoma is a disease that kills the optic nerve, okay? But its etiology is complex. It involves sensitivity to pressure in the eye. Yeah, you're thinking of glioma,
okay,
which is a form of tumor.
Okay, so the test when you get your eye test, when they blow on your eye, it's so
annoying.
Yeah,
so that's a testament. Well, they call it glaucoma test, but really what they're testing is pressure in the eye.
So your
elevated.
eyeballs don't pop out?
Yeah, that's myasthenia gravis. If the pressure is high enough, there's pain, a lot of pain actually. But the test is to measure pressure, which is a risk factor for glaucoma. But glaucoma itself is actually about sensitivity to pressure of any magnitude, and that's what separates it from the other optic neuropathies.
Okay, when you say that, do you mean like if I'm on a plane and my eyes are not happy that day, that could turn into something? Because there's a lot of pressure on a plane. What do you mean by that?
We're not talking about external pressure.
Okay.
Yeah, I mean your eye is well protected
by
the collagenous structure called the sclera, which is the white of your eye. It's a hard thing, if you can thwop your eye when your eyelid is slapped, which I don't recommend, children. The eye pushes back against atmospheric pressure. Okay, so this is pressure that is inside of the eye, right? So sperm whales, which spend a lot of time at the 3,000 feet sitting on the bottom waiting for squid to pass by, have vision, right? They don't go blind. So it's more about pressure on the inside than on atmospheric pressure pushing on the outside.
Is that a genetic disease?
There are forms of glaucoma that are certainly genetic. A small fraction are the congenital glaucomas. There's juvenile glaucomas, sure. Okay. Absolutely. When people say is it genetic, usually what they have in mind is Mendelian genetics, where you get a gene, and if you have the dominant form, you have the disease, okay? In the spectrum of human disease, those are relatively rare, okay? There are very complicated interactions between your genetic makeup and your environment and your metabolism and what you put in your body that we are only now beginning to understand. And so the question, is something genetic? Well, to some extent, everything is genetic.
I suppose that's true, yeah.
But that doesn't mean that it's inheritable. So we have to distinguish those those possibilities.
My guess is sun damage doesn't really help the eyeball too much over time.
So the eye is sensitive to ultraviolet radiation. Okay, and there's a lot of ultraviolet radiation that comes from the sun. The structures in your eye tend to absorb or reflect that ultraviolet radiation before it reaches your retina. Ultraviolet radiation is dangerous because it's got a lot of energy. And so the eye doesn't really...
Souls.
Yeah, all the souls, flying around up there. All that energy has to go someplace. And so the structures before your retina, which is the neural sheet that catches light and turns it into vision, do a great job of absorbing ultraviolet. Unfortunately, over time, that leads to things like cataract. So you're at great risk for cataract as you pass your 50th birthday, which we all look forward to.
Someday.
Yeah.
Is there a difference if I were blue-eyed versus having such dark eyes?
There's some evidence that eye color can influence the pigmentation properties of your retina. There's some evidence that it can influence the absorption spectra of the structures in your eye, but I don't think it's anything that you need to worry about.
Okay.
Yeah.
All right, I have a lineage question.
Oh, cool.
So all scientists have a lineage of the people they've studied under and then the people that they've studied under, and it goes back. It's like the family tree of medicine and science. Can we talk about maybe some of your inspirations?
I'm actually pretty proud of my lineage. So as an undergraduate at Michigan, I worked with a real hard ass named Matt Alpern, who studied and collaborated with a man named William Rushton in Cambridge, England, who was involved in some of the early papers in describing the basic conduction properties of the optic nerve, and hung out with people like Lord Adrian, who later won Nobel Prizes, and John Eccles for discovering synapses and things like that. When I was a graduate student, I got my Ph.D. with another talented guy, less of a hard ass, but nevertheless talented, named Peter Sterling at the University of Pennsylvania. And Peter studied with a scientist named Torsten Wiesel.
That is a great name.
Who, yes, and Hubel and Wiesel shared the Nobel Prize for characterizing the fundamental properties of the visual cortex, the primary visual cortex in the brain, and I'm extremely proud of that. And several of my mentors are members of the National Academy of Sciences, and I see these software programs where people, what's your scientific lineage? I try not to focus on that. I like to focus on the lessons that I've learned.
Yeah.
Peter in particular was amazingly influential in how I manage people. He was very frank with me about what my strengths and weaknesses are. He foretold frighteningly accurately what some of the obstacles I would need to overcome in my management skills in order to be an effective leader.
Yeah.
And so I most of the time when I think back about, oh yeah, I really learned this well, it goes to my dissertation advisor at Penn.
It must be fascinating to shape minds and watch them do what they do and see the things that they come up with and watch that curiosity blossom.
It's gratifying to watch curiosity blossom. Yes, it's gratifying to... I'll just tell you what my modus operandi is, okay? I don't try to shape anyone. What I try to do is to understand as well as I can everyone's individual path and their personal goals. I'm not out to make little Daves, okay? What I'm out to do is to help people find their way. Who am I to say that this would be best for you or that would be best for you? You never know, right? You never know. And so I think it's the safest way is to help people understand themselves, help people understand what their goals are, and then provide the resources so that they can reach them. Yeah, I've trained a lot of people over the years. Very few of them actually end up doing laboratory science. Many of them go on and do other things. They go on, they get other degrees. Some of them go into business, some of them go into policy, some of them go into administration. You just try to understand what people want.
Yeah.
And try to help them understand what their goals are, and then you provide substrate the best that you can.
So next step, where are we heading? What do you think your research is going to uncover in the next few years?
Right now, I am focused on general properties of the neuronal response to stress. And so I'm trying to find similarities between optic nerve disease and diseases of the brain like Alzheimer's. And so I will probably spend the next 40 years trying to come up with basic principles of neurodegenerative disease. We don't have a theory of neurodegeneration.
We don't know what Alzheimer's is yet, do we?
Well, we know what some of the etiology is. We understand what some of the genetic predispositions are. We understand what some of the stressors are. We don't have a cure. And since we don't have a cure, one can surmise that we don't understand the disease. So yeah, we don't understand the disease. But I think, if I wanted to understand quantum mechanics, I could go to the public library and I could find a dozen books that describe the theory of quantum mechanics. Or if I wanted to understand the theory of numbers, I could go to the mathematics section and I could find a number of textbooks that describe the theory of numbers with great elegance and rigor, with testable and provable hypotheses and theorems, respectively. But we don't have that for the brain. And we certainly don't have that for diseases of the brain. And so what I would really love to do is to establish what are the guiding principles of degenerative disease, a set of fundamentals that we can all start with in attempting to find new treatments.
Is there an Alzheimer's center here at the university?
Vanderbilt University Medical Center does have a cadre of scientists and clinicians working on Alzheimer's disease. We do have an Alzheimer's clinic, we have a Parkinson's clinic, we have an epilepsy clinic. Do
you work with them then?
They're all colleagues.
Yeah.
So we're all colleagues. Yeah. And we spend a lot of time just trying to speak the same language.
Yeah. It's fascinating.
Yeah.
All right. And so
Vanderbilt's a great place to work. It's
a great teaching hospital.
It's a great teaching hospital. It's a wonderful place to conduct research. It's a wonderful place to meet smart people and form collaborations.
So is flying.
As is flying, yeah. See you on the next plane.
Can you recommend some reading material that anyone who might be interested in delving even just on the surface of what you do for the layman, quote unquote?
Yeah, so there's a couple of authors that I like to recommend. I'd like to recommend Oliver Sacks because Oliver Sacks had a great fascination with weird cases, strange and rare cases, and he described them in ways that the lay public can understand. One of my favorite neuroscientists to read is a guy named William Calvin, who used to be at the University of Washington in Seattle, and he's written several books on consciousness and what it means to be a scientist. And I think that those two names are really, really, really great places to start.
I'll throw links up on the Hey Human podcast links
Sounds
page.
Great.
Yeah. Thank you so much, Dave.
It's my pleasure. These are great questions, and I hope that your listeners enjoy it.
I think they will. I certainly did. So That's a start. Thank you.
Thank you.
Bye, everybody.